SCT labs! Ah! Sky's mom sent her to the store to buy some apples, which she's going to use to make her grandmother's recipe for apple fritters. Yum! That's what it says. It literally says yum. Her mom tells Sky that it's very important to get the very best quality of apples, up to 10 pounds. If she can find that many undamaged crisp apples. The cost for a good apple is $1.89 per pound, so the cost of buying X number of apples is the cost of X, well, let's just write that one up, CX. So the cost, as it depends on how many pounds of apples you buy, is $1.89 times X. Here we ignore the cost incurred by taxes. All right, so find the domain of this thing. Well, she could buy domain. She could buy 0 apples. And I would say that the domain ends maybe over here at 10. I should put brackets on those because she could buy exactly 0 apples. And it goes up to 10 pounds, but I don't know if that necessarily includes 10 pounds, so I'm going to put a little parentheses on that end. Or, this is in interval notation. In set notation, that would look like X such that X is between 0 and 10. Little squiggly brackets on that side. All right, cool. So if I were to graph that, okay, that's pretty simple to graph. I can just do a graph like this. And here is $10, here's $20. Okay, so if she buys 1 apple, it goes up to about a 2 over here. If she buys 10 apples, or 10 pounds of apples, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, way out here, it goes up to 18, because 10 times 18.9, so almost 19. Something like that. I would say that my graph should probably look something like a straight line like that. All right. So check this out. Here's the thing. My question is, or at least this is the question they're asking me, is it possible for Sky to buy exactly 2/3 of a pound of apples? Well, sure, I can plug in 2/3 into here. That's $1.89 times 2 over 3. 2 over 3 is also known as 0.666666666 in forever and ever, so that's 1.89 times 0.6666666, and so on and so forth. All right, plug that into your calculator, you'll get an answer. So the answer is yes. Mathematically, it's possible. Now, physically, is it possible for her to buy exactly 2/3 of a pound? Well, here's the problem. The scale that the grocery scale uses, they don't use scientific balances. They don't use the $5,000 scale that you find in a big chemistry lab. They use I don't know, Baker scales, which are pretty accurate, but they only go up about this many decimals right here. So all of these is out. So technically, you couldn't buy 0.666666666 equivalent of 2/3 of a pound. You can only buy 0.66 of a pound, or actually probably more like 0.67 because we would round that up. So technically, you can't buy exactly 2/3 of a pound using a regular scale. Now, if this right here, okay, by the way, this is 10, you go up to 0 pounds to 10 pounds. If this right here, say that we've restricted ourselves to now, what is now the domain if the thing is only able to register 1/10 of a pound. So let's say, it only is able to register up to that decimal place right here. Then I won't even be able to buy 0.67 pounds. I can either buy 0.6 pounds or 0.7 pounds, but I can't really get that accurate. How does that change my domain? Well, it changes it a little bit. If I were to zoom into this right here, it would be, I'm just going from 0 to 1. The graph actually goes all the way up that way. I'm just zooming in over here. So instead of going up to 10, so it only goes up to $1.89 at 1. This corner. There we go. Straight line. It would be a straight line, but technically that's not true, because that's suggesting that I could buy 0.5786 pounds, like right here. And the scale that we have doesn't register that accurately. So what this graph is going to end up looking, what your domain is now going to be, really is these set integers. So like at 0.5, it will charge you this much money. But at 0.55, here's 0.6. At 0.55, halfway in between, it will charge you the same amount of money. So it's almost like there's a jump, right? Or that, you know, there's a straight line over there. And then once it hits 0.6, it's going to jump up to the next cost and then charge you that. Now, of course, there's not these vertical lines. And I believe that maybe there's an open circle here and a closed dot here. Open circle, closed dot here. So technically, this is the more accurate version of this continuous graph. Mathematically speaking, the continuous graph is accurate. Physically speaking, this little, I guess they're called step functions, because I kind of think of them as steps that kind of go up, is more accurate as far as, you know, the domain in context. Now usually people will just graph it like this, and then they'll say, well, you got to think about it in context if you really want to understand this graph. They don't usually actually go through and make these things, but I'm just telling you, technically, if we were to zoom in, it should look like this little steps right here, depending on the accuracy of your scale. Now, if your scale that you have can actually measure out 0.0001 pounds or something like that, then of course these little steps will get smaller and smaller and smaller. And if you can make that scale super accurate, like 0.00000001, then you'll eventually just kind of make these steps so small that it'll end up looking exactly like that straight line. Shoots, bro! Up out!